Are you throwing away your money by wasting your CNC machine? Today I wanted to talk to you a little bit about balancers and height setters combined into one ultimate machine. I have a video from Heimer starring none other than Brent Holden, president of Heimer. And I'm going to jump around in the video. I'll put a link in it below. I want to talk to a little bit about it. And I'm going to step through some of the extra value I see being a machinist, having been on the shop floor dealing with a lot of this.
The goal of this, of course, is to really just give you the most consistent setup each and every time.
Setting up your tools while the spindle's turning and earning. We all love how much I love turning and earning spindles, right? You can do all of what Brent's about to demonstrate while the machine's already running and you're getting ready for the next run. Maybe you're in mold making, you're running lights out, or you're just looking to have the tool set up and ready to pop into the machine without wasting that spindle time. Everything he's doing can be done while the machine's running. I don't know how many shops I've worked with now, and I walk in and the guys are doing this all on the machine. Now, I mean, I get it. That's the way I did it at most of my shops. But when you start to recapture that lost time, it now means you're running more, which means you're making more money, you're more profitable. Investing in a solution like we're about to see is really a no-brainer. Like, are you going to take time on your $250,000 machine, your $100,000 machine, your $150,000 machine, taking the hours from that machine and the value it adds to your operations so that you can measure and balance and troubleshoot? And I'm going to share a little bit more as we continue down through this video with Brent.
We've got a new software called the DAC. It's something that can help walk yourself through this process, but in simple terms, what we could do is scan either the QR code, data matrix code on the holder, or even the QR code that we printed out earlier on a presetter. This would tell us where to go. It would tell us where to go find the tool. So for instance, in this case, we're gonna go find our tool holder. So here's our tool holder in this case, a power shrink from Heimer. Tells us where to find the cutting tool. So we look in the drawer, we find our 10mm power Heimer mill, and we come on over.
Now, Brent makes that look easy, but what does that look like in your shop? That's what I'm curious about. I know the shops I've worked in, I'd be looking through what was on the rack, and then I'd be going to look through the machine carousel to see what I could possibly see in there. Maybe I'd tab a couple, because you know how when you're looking at the carousel, there's always a couple that you can't see for some reason there, and you're convinced, right, that holder you're looking for is in the section. So you jog the machine, the carousel, the belt, whatever happens to be there. In this setup, it's right there. It's right available. If you're the one buying the tools, you might be like, yeah, but Arthur, that's money that could be. You're totally right. But what is your time worth? Seriously. What's more important? Are you out to save a few bucks? Or are you out to spend your time more efficiently and earn tenfold on your investment? There's no right or wrong. But you need to powerfully choose. What's more important?
So this is our Profi Premium Plus shrink fit machine, which we haven't talked about yet, but this machine has the ability to shrink from 3mm to 50mm, or 1/8 inch to 2-inch capacity. So what I'm going to do is get this ready to go. It's got our motorized coil. So in this case, we're just going to tell it which diameter we're shrinking. This is a 10mm shank tool. We press this button here and the coil will automatically go to the correct position. I'm also going to set the Z-axis height. So for this example, I want to be at, and this is another thing that our i4.0 series will be able to do, is guide you through where you want to set this tooling assembly at once you have the data.
Yeah, and it's such a great system. I've been trained on the newer update of this system. This video is a year old and technology is always advancing. You can actually scan with your heat shrink system and it will set the proper temperature, everything, as well as you can see over here on the wall here above that there are temperature, like these are cooling collets. They've got little lights above them. They tell you what's going on with it, so you never have to burn a hand again. I don't know if you've ever done shrink fit, but that's usually the first thing you're like, oh, it's, and you totally forget someone else switched a tool, whatever happened, and you grab that holder and you burn your hand. Really love this system, but I don't want to go too far into the weeds on this. Now, something to pay attention to is Brent's taking his time, really doing a great job explaining this clearly. And this video is not even 10 minutes long to go through the whole process. He's going to go through all the heat shrinking, the cooling. Let's see, that's the induction. That should be the cooling there. The cooling's all over here still going on. You can see that red button I was talking about. Okay, now I'm going to let Brent talk.
And the idea of doing this is doing it off the machine. So the machine is running right now. So you're setting up the tools for the next job. That's really important as it relates to really maximizing your time and maximizing the uptime on the machine.
Yeah, I completely agree with Brent here. Setting this up, keeping whatever you can do to keep your spindle turning and earning you money, putting value into your parts, that's really your mission. And that's where I focus on. And that's how I help the companies I work with save hundreds of thousands of dollars. There's all this other like world of stuff like, oh, It's like, no, look, like what's going to keep that spindle running? We're going to do that. You're going to save tons of money. You're going to love it. Also, have a look at this in the background. Watch.
Resetting, while of course,
boom, automatically comes up, lets you know when it's safe to grab. Sorry, I love the level of quality and care and really the customer experience that Heimer puts into their products. Yes, I'm totally a fanboy, but it's because of the care they put into these products.
So it's actually got two softwares built into one, both presetting and balancing.
If you notice there, when he pulled the arm back, it brings up the balancing screen.
So in this regard, or in this example, we're going to balance the tool first. We've got balancing rings on this holder. So I place the tool holder into the machine, ramps up. We're trying to balance this tool holder to G2.5 at 25,000 RPM.
Yeah, now your standard holders that you buy, most companies make them to G2.5 at 25,000 RPM. However, that only applies to the naked holder. Once you put a tool in, no longer balanced. Watch the numbers that start to come up.
This is the full assembly, of course, as it will run the machine tool. It takes a reading. As we demonstrated earlier, we index the tool 180 degrees and take another reading.
Yeah, now that just gets out any imbalance that might be in the spindle that comes in the balancer.
So we truly just get the unbalance of the tool holder assembly. We're going to show you doing balancing rings. This is a method of displacing weight to bring the assembly into balance. So now it tells us we're not balanced. We are balanced at G2.5.
Oh, sorry, Brent, I totally cut you off. He's about to give us the numbers. It's right here. This machine has lasers that it can target so it can help you find it. So these little balancing rings down here, I'll have to blow it up in post, but it's hard to see. But there's these rings right there at the bottom of the holder. Look at the mouse cursor. That's going to be the easiest way. So if you look here, those little black rings is what he's going to be adjusting. Now let's go back to where he was just talking about those numbers and the results.
At 5,400 RPM. At the 25,000 RPM, we're at G11.3.
Yeah, so there basically he's saying you're going to get that G2.5, that harmonic balance, only up to 5,000 RPM. So if you're programming your tool under 5,000 RPM, you're not going to have an issue. However, that's, what did he say, an 8 mil tool? So we're talking around, that means you're really not going to get a lot of SFM out of this. Hold on. Yeah, you're not even going to get 500 SFM. 500 SFM would put you over at 6,000. So depending on the materials you're running and the cutters you're using with the new coatings that are coming out, you're going to be seriously hampering your performance. What does that look like at the spindle? Well, at the spindle, that looks like scratching your head. I mean, geez, these tooling manufacturers, they told us it was going to cut at this speed. Now, are you going to get lucky sometimes? Yeah, you're going to set it up and you're going to get lucky every once in a while setting it up. And you're going to get it flawless. And then you're going to go to do that setup again. And you're going to have all this crazy vibration and shitty finish. And you're going to be scratching your head wondering why. Because you're literally like chucking the dice every time you mount your tool. Gee, am I going to be balanced to the RPM range that I'm programmed at? Or am I going to be fighting it? Having been the machinist on the shop floor, I can tell you how absolutely infuriating that is. To do everything you know to do and still come up short? Let's go, Brent.
So what does it tell me to do? It tells me where to position each ring. And again, each ring has a known unbalance built in.
And he's going to tweak this. I'm going to jump ahead because I have a feeling this video is getting long. But so Brent's going to tweak this. The lines here are going to move, so watch over here on the screen.
And there's clear indication on the machine where to position the ring based on a scribe line, which would be impossible to see on the video, but there's a scribe line on these little rings.
Yeah, now that's the black rings I was talking about. What we're watching is right here, right? I just realized the cursor is behind my head, but this little diagram.
I'm just loosening a screw and then placing it in line with the laser.
Right, and you can see
the
that
laser
laser.
gets brighter when you're in the right position. We do this
And you
one
watch,
as
it rotates on the screen. So where that line is rotates on the screen as he's going.
well. So now we lock it down. Of course, we need to confirm, are we still...
Yeah, always
the
check it
down
again.
Just to try to show real life tool.
Here we
Here's
go.
our results. So we're currently now at G 2.2 at the 25,000 RPM.
Now the G balancing series, it all has to do with forces, resonance, vibrations, all of that. 2.2 is above the standard, extremely rigid, insanely rigid is where that is. So many people think balancing only matters if you have more than a 10K spindle, and even an 8 mil is gonna suffer trying to go over 5K RPM. And it's not because your machine can't do it, and it's not because the material's too hard, and it's not because you're using the wrong end mill, because your tool's unbalanced. You're wasting your time. So what's your time worth?
Green is a good indication that we're balanced. It's time to preset. So again, utilizing the exact same machine,
So he's gonna bring in the presetter. Have a look at the screen as he does that.
we can preset it here. So now what we do is we come over, again, using our handy edge detection feature.
There's the handy
Bring
edge
it in so that
detection.
we can see where we're at, and we get ready to measure the tool. Now, one thing I'm going to do in this tool that I haven't showed yet is actually use the sigma function. As you see, we're exactly at 6.7 inches, but I'm going to use sigma. Sigma is a neat function. It actually finds the highest Z and X dimension as you rotate 360 degrees. So we're just slightly over 6.7 inches in the gauge line. So that's exactly what we tried to accomplish with the shrinking part. And here's our Z dimension here. At this point, we can print out a label, bring it over to the machine, manually enter the data, or we can send the data directly to the machine tool via a post processor, or we can have even a manual RFID system where we can read a data chip on the holder. So again, that's really the whole setup process of getting the tools ready to go. And with Heimer, we're always trying to give you the best and most consistent tool holder assembly possible so that you can really get the max out of your machine tool. So that is really the takeaway that I'd like to stress here today.
And I appreciate that, Brent. That philosophy, the core foundation of Heimer, is one of the reasons I'm such a fanboy of the equipment, because it's all about keeping your spindles turning and earning.